FIFO replacement algorithm. First of all, we need to bear in mind a few terms and rules of FIFO algorithm. The rule of FIFO algorithm, we can simply say that the oldest will be removed. In this example, there are 7 number of pages and page stream. The sequence number of page streams are 9, 4, 9, 5, 7, 8, 6. This number actually will be executed by the CPU. Next, we have 3 frames. Since we assume our RAM consists of 3 slots only, we also have page fault when it involves transfer of data from hard disk to RAM. Now, let's see how the FIFO algorithm works. Initially, the frames are empty. The first number in page stream, which is 9, will enter the frame, and here got a page fault as it involves transfer of data from hard disk to RAM. Then, the number 4 will be executed in the second frame. Also here got a page fault. Next, it's number 9 again. However, there is no page fault since we use again the number. Then, the number 5 will be placed in the third frame with a page fault. As you can see now, the frames are full. Then we have 7. The number 7 will enter the frame, and 7 will replace with 9 because 9 is the oldest. Remember the rule of FIFO that I mentioned before, the oldest will be removed. Here also got a page fault. And next we proceed with number 8. The number 8 will replace with 4 because 4 is the oldest. Here also got a page fault. And finally, the last number in page stream, which is 6. It will replace with 5 because 5 is the oldest. And also here got a page fault.
So let's start with the LRU. What is LRU? LRU stands for the least recently used. In this algorithm, page will be replaced is the least recently used. So we're going to replace the page that hasn't been referenced for the longest time. And LRU works on the idea that page that have been most heavily used in the past few instructions are most likely to be used heavily in the next few instructions too. Here's the overall example of LRU that I'm going to explain. In this example, there are 11 number of pages and page streams. There is nothing in the page frame before, and the current page is 3. So 3 will be added here, but there will be a page fault. What is actually page fault? Page fault is page which is requested by the program that is not present in the RAM. The next page is 7. As there are space for 2 more pages, 3 will remain there and 7 will be added, and again there will be a page fault since 7 is not present in the RAM. Next page is 5, which is not in the page frame, but there is 1 more space, so 7 and 3 will be remain there and 5 will be added, and there will be again a page fault. And we can see here the page frame is now full. Next page is 6, which is not there in the page frame, and we know that the page frame is now fully occupied. So we need to remove 1 page from the page frame in order to add 6 into the page frame. As we mentioned before, the least recently used is the one which we're going to be removed. 5 is the most recently used, then followed by 7 and 3. As 3 is the least recently used among the other numbers, so 3 will get removed and 6 will get added there. And again, there will be a page fault because 6 was not present in the page frame. The next page is 5, which already present there in the page frame, and is known as a page hit. 6, 7, and 5 will remain there in the page frame, as the page which is requested by the program already present in the RAM. This is why it is a page hit. The current situation of the page frame is full. Again, we see the next page is 4, which is not there in the page frame, so we need to remove one page from the page frame in order to add 4 into the page frame. And 5 is most recently used, which then followed by 6, 5 again, and then 7. As 7 is the least recently used among the others numbers, so 7 will get removed and 4 will added there. There will be again a page fault because 4 is not present in the page frame. Page frame is again full. The next page, as we can see, there is a 3, which is not there again in the page frame. So we need to remove one page from the page frame. 4 is most recently used, which then followed by 5 and then 6. As 6 is the least recent used among the other numbers, so 6 will get removed and 3 will get added there. There will be a page fault because 3 was not present in the page frame. Next page is 2, which is not there in the page frame, and the page frame is full, so we need to remove again one page from the page frame. 3 is the most recent use, which then followed by 4 and then 5. As 5 is the least recently used among the other numbers, so we will remove 5 and 2 will get added there. There will again page fault because 2 was not present in the page frame. Next page is 4, which is already present in the page frame. 3, 4, 2 will remain there as it is page hit and page that is requested by the program is already present in the RAM. Next page is 3. 3 is already present in the page frame. So 3, 4, 2 will remain there as there is a page hit. Next page is 5, which is not there in the page frame. And as we can see, the page frame is already full, so we need to remove one page from the page frame. 3 is the most recently used, which then followed by 4 and then 2. As 2 is the least recently used among the other numbers, so 2 will get removed and 5 will get added there. And there is also page fault because 5 was not present in the page frame.
Now we will proceed to OPT algorithm, which is optimal page replacement algorithms. OPT algorithm can be defined as with the likely used page in the nearest future. For easy understanding, OPT algorithm can be meant by replacing a page that will not be used in the near future. There are 3 important reminders that we must remember before understanding OPT algorithm. First, page stream is the sequence of data that will be processed by the CPU. Second, we are assuming only 3 frames of RAM, which means only 3 slots of memory is used. And the last one, page fault involves transfer of data from hard disk into RAM. Now I will explain how the OPT algorithms executes. We have an example of a sequence of data in page stream which are 3, 2, 1, 3, 4, 1, 6, and the last one is 2. Initially, the frames are empty. Okay, so first, data in the page is number 3. Page fault occur and the number 3 will transfer into one page of memory. Next is number 2. Page fault occur and the number 2 will transfer into another page of memory. Next is number 1. Page fault occur and the number 1 will transfer into the last page of memory. Next is number 3. Page fault is not occur because the number 3 is already available in the memory. and will be used in the CPU. Next is number 4. As we know, all the 3 pages of memory are full. Remember definition of OPT algorithm, which is replace a page that will not use in the near future. In this example, the number 3 is a page that will not use in the near future. Page fault will occur and the number 4 will replace number 3 in the frame. Next is number 1. Page fault will not occur because number 1 already have in memory. Next is number 6. Currently, number 2 is the number that will be used in the near future. So, we can either replace number 4 or 1 using first in, first out. The number that number 6 will replace with is number 1. Page fault occur and the number 6 will replace number 1 in the frame. And the last one is number 2. Page fault will not occur because number 2 is already have in memory and the CPU complete the process of the page stream.
Now let's see an example. So on this example, there are 11 number of pages and page stream. We have a sequence number of page stream 3, 7, 5, 6, 5, 4, 3, 2, 4, 3 and 5. So now let's see how the clock algorithm works. First, the arrow pointer was pointing to the first frame. So 3 will be placed in the first frame with use bit and the arrow pointer will move to the second frame. Now 7 will be executed. 7 will be placed on the second frame and 7 will have the use bit. Now the arrow pointer will move to the third frame. Then 5 will be executed. So 5 will be placed on the third frame with a use bit. Now the arrow pointer will be pointing again to the first frame. Then 6 will be executed. But 6 cannot replace 3 because it has the use bit. So here is the important part. At first, the arrow pointer point to 3 that has the use bit. When it has the use bit, it cannot be replaced. So what will happen next is arrow pointer will move to the next frame pointing to 7 and 7 will lose the use bit. Since 7 has the use bit, it cannot be replaced. Then the arrow pointer will move to the next frame pointing to 5. So 7 will lose its use bit. 5 also has the use bit. Then it cannot be replaced with 6. So the arrow pointer will move again to the first frame pointing to 3. Now 3 doesn't have the use bit. So it will be replaced with 6. And then the arrow pointer will be pointing to the next frame. Now you notice that on page 5, the page stream is 5 and the arrow pointer pointing to 9 but 5 already in the third frame. So what will happen is 5 will get again the use bit and the arrow pointer will not move. Now we go to number 4. 4 will replace 9 and the use bit is set and the arrow pointer will move to the next frame. Now the arrow pointer point to 5. So we go to the next page stream which is 3. Here you can see all the frame has been occupied and each of them has the use bit being set. So we repeat the same process like page stream 6 that we have discussed earlier. Pause this video and try to calculate by yourself and check if you get the same answer. For the next page stream 2, 2 will replace 6 and the use bit is set. Then the arrow pointer will move to the next frame. Now we go to the next page stream 4. 4 already in the frame but it doesn't have the use bit. So we set the use bit and the arrow pointer will not move. Now the next page stream 3. 3 already in the frame and it also has the use bit. So nothing will happen and the arrow pointer will not move. Now let's see the last page stream which is 5. Since all the frame has been occupied and each of them has the use bit, we need to repeat the same process again. The rule is, if an attempt to replace a frame with use bit, the frame will lose its use bit and the arrow pointer will move to the next frame. So that's all for clock replacement algorithm. I hope you understand this very well, and please share this video with your friends. Don't forget to subscribe and like this video.